Hello everyone. Today we will see examples on Fredholms first theorem. Okay. First example, equate the resolvent for the integral equation. Okay. This is the equation, integral equation g of x equal to f of x plus lambda integral from 0 to 1 s plus t. Okay. This is the kernel which we had given and g of t dt. Okay, solution for this example, we will find this solution by writing this. Okay, we have to find a resonant kernel. Okay, that is resonant kernel of s comma t comma lambda, which is equal to, this is the formula to find summation growing from p equal to 0 to infinity, in bracket minus lambda raised to p upon p factorial into cp into s comma t. The whole thing upon summation from p to 0 to infinity, in bracket minus lambda close the bracket raised to p upon p factorial cp. Okay, this is different cp and this is different cp. Okay, this both are different. This is capital cp and this is small cp. We have to find both this, and with capital cp, to find capital cp and to find small cp we have different way. Okay, first we have to take c naught. Okay, we have to find c naught, and here only resolvent is 1, so we have to take is equal to 1. Okay, then we have to find c naught for kernel, that is s comma t, and which is equal to kernel s comma t, and in this equation it is given as s plus t. Okay, then cp, which is equal to find the cp, the formula is cp equal to integral cp minus 1 s comma s ds. Okay, this is to find small cp and this is to find the capital cp. The capital cp is given by small cp kernel minus p integral from 0 to 1 k s comma x capital cp minus 1 into x comma t dx. Okay, first we have to find c1 for x comma s comma t. Okay, for to find this, in case of here we will first take 1, so in cp we will get c1 of s comma t, which is equal to s plus t minus integral from 0 to 1, and here the kernel, which is s comma x and x plus t. Here is the formula, we had only substitute this. Okay, here in this problem we had given that is s plus t, so we have to substitute here s plus x. Okay, this by this formula, and x plus t, which is equal to, after substituting this integral we will get equal to half into s plus t close the bracket minus st minus 1 by 3. We will get c1, we had got this half s plus t close the bracket minus st minus 1 by 3. Next we have to find c2. Then c2 we means small cp, and for to find this formula is integral cp minus 1 s comma s ds. Okay, so c2, which is equal to integral from 0 to 1 s minus s square minus 1 by 3, and this cp minus 1 we had already find, that we have substitute, we have to substitute here, and in case of t, we have to only take t, s minus t square. So after substituting the integrals and finding the value, for substituting 1 and 0, we will get c2 is equal to minus 1 upon 6. Next we have to find a c2, that is capital Cp, and for that is capital Cp s comma t, which is equal to minus 1 by 6 bracket x plus t minus 2 integral from 0 to 1 s comma t bracket 1 by 2 x plus t minus x t minus 1 by 3 close the bracket. And after substituting this and finding the value, we will get 0. We are getting 0 since x2 s comma t vanishes, means we are getting 0. So the subsequent coefficient, so ck means cp, capital Cp and also small cp also vanishes, so, because we are getting 0 here. c2 s comma t is 0. Therefore the resolvent we will get s comma t comma lambda, which is equal to s plus t. Okay, this is in the problem, in that equation, integral equation, minus bracket half into bracket x plus t minus st minus 1 by 3 whole thing into lambda whole thing divided by 1 minus lambda minus, open the bracket, lambda square by 12. Okay, this is the solution for this equation. We will see the second equation, solving the integral equation. Here the integral equation is g of x equal to s plus lambda from integral 0 to 1 in bracket st plus st half means square root. Okay, this st has square root g of t dt. Okay, in this case c naught is 1. Okay, we had here and not given anything, so we can understand that it is 1, and c of st we have to find, and that is the kernel. Yes, we know that x, actually it is kernel of x comma t, but here it is x. So c of x comma t is equal to, given by, this is in the problem, st plus st raised to half. Okay, this is the kernel. Okay, now from this we have to find capital Cp and small cp. To find the small cp, the formula we had already seen, that is the integration from 0 to 1, and we have to take this as x square, we have to add s, and we have to, after finding this integral from 0 to 1, we are getting the value as 5,6. Okay, this is the capital Cp. Now this is the small cp. Now capital Cp, which is s comma t, after substituting in that formula which is first we had seen, then we, after substituting this, raised to half minus 2 by f st half plus ts half, we will get this. Okay, this is the final answer for c1 s comma t. Next we have to find c2. Okay, this is the small cp. Okay, we know the formula, that is integral 0 to 1. We have to substitute this capital Cp in finding the c2, that is next c2, and after substituting this we get 1 upon 75. and here 1 upon 75, and now we have to find a C2 x comma t, that is kernel s comma t, and here also we are getting 0. Okay, so C2 s comma t vanishes in this also. In first problem also we seen we are getting 0, in second problem also we are getting 0. So therefore all the subsequent coefficient vanishes, because C2 we are, if we are getting 1, this C2 1 0, then we have to say that all vanishes. Therefore the resolvent, therefore the value for the resolvent kernel is, that is resolvent kernel r of x comma t comma lambda, which is equal to st plus s of t raised to half minus, open the bracket, half st plus 1 by 3 st raised to half minus 2 by 5 bracket st raised to half plus s of half t close the bracket lambda, the whole thing divided by 1 minus 5 by 6 lambda plus close the bracket 1 upon 50 close, open the bracket, now 1 by 150 close the bracket into lambda square. Okay, we are getting this after substituting all this in this equation, that is the kernel, resolvent kernel. Therefore the solution g of x is given by g of x 150s plus lambda in bracket 60 half. So s raised to half means root of s minus 75s close the bracket plus 21 lambda square s whole thing divided by lambda square minus 125 lambda plus 150. Okay, this is the solution for this integral equation. Third problem, g of x equal to 1 plus lambda, this problem, and this is integral we have from 0 to pi into sine of x comma t gt. Here c naught is 1, because yet here we don't have value for lambda, so it is equal to 1. Now c of t xt, we know this is the kernel, and here kernel is given as sine of s plus t. Now we have to find the c1, which is equal to integral from 0 to pi sine of 2s plus ds. We have only here s. Okay, here we have to 1, so we have to add 1, so 2s ds equal to 0. Next we have to find this is capital CP, that is in the kernel formula, which is c1 x comma t, which is equal to 0, because CP, small CP we are getting 0, so directly here 0 minus integral 0 to pi sine of s plus here with respect to x, so we are substituting here x sine of x plus t, so this is the kernel dx. After substituting this value we are getting minus half pi cos of s minus t. Now we have to find c2, which is equal to, this is small cp, which formula is integral from, so here minus integral 0 to pi half pi cos of 0 ds, which is equal to minus 1 by 2 pi square. So we have to find a kernel, it is capital CP s comma t, here means it is c to s comma t, which is equal to minus 1 by 2 pi square sine of x plus t plus 2 integral from 0 to pi half pi sine of x plus x cos into in bracket x minus t dt. Okay, and here also after substituting these values here also we are getting 0. Okay, therefore so the all this vanishes, because the s2 we are getting 0. So therefore the resolvent kernel is as this is the resolvent kernel, we denote this as s comma t comma lambda, which is equal to sine of x plus t plus half pi lambda cos of x minus t whole thing divided by 1 minus 1 by 4 pi square t lambda. Okay, therefore the solution is g of x is equal to 1 and we have to substitute this in case of this problem, that is the kernel. We have to substitute this 1 plus lambda, we are getting that is 2 lambda cos of x plus lambda square pi sin x 1 minus 1 by 4 pi square lambda square. This is the solution for this integral equation, that is g of x equal to 1 plus lambda integral from 0 to pi sin of in bracket x plus t dt gt dt.